So thank you very much, everyone. This is the waste management session of Climate Robotics Summit. I am Berk, an associate professor in Robotics Engineering Department at Worcester Polytechnic Institute, WPI. It is located in Massachusetts, United States. So the topic of this session, waste management, it's a very active topic in climate robotics, and it also has a lot of presence in the public discourse because that's something that many people do day by day. Many people get engaged day by day. And the waste generation problem will only get worse. It is projected to increase in the near future. So it is really important to have scalable solutions, and robotics can definitely help in that respect. And of course, it's a very broad topic. There are many types of waste that humans generate. For example, we generate municipal waste, some electronic waste, industrial waste, organic waste, construction waste, etc. And it is not possible to cover every single aspect of that. But all these problems sometimes have some commonalities, sometimes some unique features, and sometimes some intermingled features that are touching each other in different ways. And the problem of the domain, we won't be able to cover, of course, all of these, but we have an excellent set of panelists. We will be focusing on their expertise, deep expertise on certain subsets of these problems. Before I go for a round of introductions to our panelists, I would like to encourage everyone to post their questions to the Q&A tab. We will definitely direct it to our panelists. So without further ado, I would like to ask Minghui to introduce herself. Thank you.
Hi, thanks, Berk. Hello, everyone. I'm Minghui Zheng, currently Associate Professor at Texas A&M University in the Mechanical Engineering Department. My area mainly focuses on how to utilize robotics and human-robot collaboration to help with the e-waste recycling and remanufacture. So at current stage, we mainly focus on the disassemble first. So that's my background. Thanks.
Thank you very much, Minghui. Rupesh?
Yep. Hi, everyone. My name is Rupesh. I'm the CEO and co-founder of Revise Robotics. I'm also working in e-waste, but more in the refurbishment and reuse of electronics. So every year, there are more than 50 million tons of e-waste being produced around the world. These have tremendous implications, both socially and environmentally. So starting with environmental, there are just so many critical materials in these devices: laptops, TVs, desktops, video game consoles, ranging from gold and palladium all the way to lithium and copper. All these materials, these critical materials, their supply chain is being very, very stressed right now due to tariff situation, due to world conflicts, geopolitical conflicts, and also the need for these materials throughout the electrification process. Some of the same materials you need to build an EV are the same ones you find in, say, a laptop. And so one of the goals of urban mining is turning the attention to all the materials we already have in urban centers and mining the metals out of those sources before we turn to virgin materials. And so of these 50 million tons that we produce, we really think that we can pull a lot more materials from them through automation. Same thing socially. There's a concept called the digital equity divide, which references the unequal access to technology, whether that might be laptops, computers, internet access. During the COVID-19 pandemic, like more than 15 million children didn't have access to technology to do basic things like their homework and online learning in the United States. And so we believe that a major reason why all these devices remain in the landfill, in the e-waste pile, is largely because of the time and labor it takes to actually pull out the valuable materials out of them. Now, I've talked a lot about the critical materials, but at Revise Robotics, we're focusing on lengthening the lifetime that these devices can have, mainly through refurbishment. So we're not doing any disassembly yet. We're taking, say, 100 laptops, figuring out what condition they're in, doing inspection, triaging, refurbishment, and resale of used electronic devices entirely through robotics.
Thank you so much, Rupesh. Very interesting. Barbara?
Yes, thank you. Thank you, Berk, and thanks for having me. My name is Barbara Reck. I work at the Yale School of the Environment in a field called industrial ecology, and I am not a roboticist. And so I have worked Rupesh gave the perfect introduction actually to the kind of work that I've been doing for many, many years, which was really looking at these material streams from a broad perspective, these, among others, critical materials that you just mentioned, trying to understand how we're using them. So we did a big material flow analysis from ore extraction up to waste management, trying to understand how we are using these materials and defining also and understanding, identifying the yield losses along the way, understanding where would be basically any interaction be most impactful. And all this work really aimed at, well, end of life management is the toughest spot. And recycling, and there's a lot of, not recycling happening, and even the recycling that's happening is often actually downcycling. It's associated with a lot of contamination. So I'm actually more this sort of, why do we need better recycling systems? That's sort of where I come from. And then a few years ago, Berk actually approached me and sort of said, Barbara, we are proposing this nice big project, and we have this crazy idea to add these sort of robotic sorting to material recovery facilities. So that's basically when you throw your trash regularly in the trash, or you have a second bin for recycling for household waste. So this is looking at municipal solid waste, and municipal solid waste is recycled in these special MRFs, as they are called, material recycling facilities, through a combination of magnets, eddy currents, and jet streams, and a lot of different sorting. But until very recently, robots was not one of them. So we explored this together, and we can talk about more about this later. Thank you.
Thank you so much, Barbara. We definitely will benefit from your perspective in this panel a lot. So Minghui, so you are focusing on robotic disassembly, which is a very important task for facilitating the waste management problem. But you are also approaching it in a very useful perspective, which is the future of work perspective, looking not only the development of technology, that is definitely a very important concept, but as well as its economic and occupational aspects. Could you please talk about your research on this subject more? Thank you.
Yeah, thanks for raising this question. Actually, yes, as you mentioned that we actually are a little bit bigger team. We have people working on robotics, works on human, works on occupational safety and labor force. And from the future of work perspective, I think I want to highlight two things. Currently, because for the e-waste disassembly, it's still mainly done by labor, because the robot technology is still too expensive to actually apply in this domain. So how to handle this case, how to make robotic cheaper, but we're not trying to replace human workforce. Actually, it's very hard to do so. But we're trying to augment human performance such that there will be more jobs in this domain to promote the e-waste disassemble, e-waste recycling. So, and also we need to consider occupational safety and also the safety of the robotics. So introduce robotics to a relatively less constructed environment is not easy. We need to consider a lot of issues. The safety is definitely the priority. So how to design robot to make sure that human is safe, how to train the human workers to adapt to robot technologies in such dynamical environment is also a challenge. So we mainly focus on, other than robotic technology perspective, we also focus on how to let human get used or adapt to these technologies, and how to make sure that we are prepared for the future of work in this domain.
Thank you so much. And Rupesh, can you talk about the technology your company has been developing, please?
Yes, sure thing. So we're using an off-the-shelf robot arm called the X-Arm from a company called UFactory. So we decided not to custom build our own robot from scratch, just because the basic things that we need of 6-axis motion are already available on the market. The unique technologies that really enable what we're doing are two things. So if you imagine a laptop, being able to interact with it is a very contact-rich task. So you have to do a lot of things like opening the lid, pushing buttons, plugging in cables. We're using a force torque sensor in order to be able to do a lot of these fine motions. So being able to provide, just enough force to insert a USB, but not so much force that you are, destroying the port, or pushing a button with some minimum amount of force. This is something that has come down in cost tremendously over the last decade, and it works really nicely for our use case. The other main thing that we're using is computer use and AI. So if you imagine, one of the main things about reverse logistics and circularity in general is that unlike manufacturing, you receive any kind of feedstock. So for us, we receive any laptop from any manufacturer. It can be in any condition. And so in order to process every kind of device out there, it's extremely difficult to come up with a rule set beforehand. If you see this laptop do exactly this. One main use of the AI that I'd like to highlight is in the computer use. So for example, if we want to erase the hard drive on any laptop that comes in, we leverage, say, OpenAI's computer use model, KUA, in order to navigate any software menu and achieve this high-level goal of wiping the hard drive without pre-specifying, press right 3 times, F2, then enter. This is all handled by a computer use model that's already been trained on the entire internet, as well as many, many, many user interaction behavior patterns.
Wonderful, very interesting. These, I can imagine, are like very interesting robotic manipulation problems that you are dealing with. And yeah, it's also very cutting edge. Barbara, again, being from the Yale School of the Environment, you are bringing a very important perspective here. You have been running many techno-economic analyses. You also have been focusing on scenario analysis frameworks as well. These kind of frameworks are quite important to understand the landscape of these technologies and how they can be integrated, and what could be some potential benefits of these. Could you please give more details about your work on those fronts?
Yes. So the idea was basically to understand, well, what's the potential of robots in waste management or in these MRFs, not just today, but also in the future? Because so we started our research project in 2019 when robots were still a very, very small thing. But then came the pandemic a year later, and all of a sudden everybody realized, oh my goodness, all the workers are calling in sick. So we have no workers. So maybe robots are actually a really good thing because they're reliable. You don't have the safety issues. They don't face the risk of getting hepatitis C from needles or things like this, because there's a lot of risk actually it's in all this. So trying to understand, well, where is all this headed, but also what are the key factors that make basically a restructuring of the MRF sort of valuable, and sort of what are the key factors. And what we found is that in general, MRFs are I think for roboticists, a rather frustrating environment, in the sense that it's messy. It's messy. It's a very mixed material streams, and in addition to, I mean, first of all, you have metals, you have different metals, you have all kind of different containers, you have a paper from large cardboard boxes to small little pieces, shredded paper. So how do you make sense of that? That in itself is enough of a challenge. But then you have people throwing in all kind of other stuff that's not supposed to be there. That some of this, yes, you have sort of at the beginning, at the MRF, there is this so-called pre-sorting station where people manually remove remove the watering hose from your backyard, which is not supposed to end up in there, but it does. So, but then some things are not being picked up. So it's a tricky environment. The second thing that's equally frustrating is to make an economic perspective sort of what's going on, you need some sort of planning certainty. The problem is that the commodities, meaning the different recycling streams that the MRF is supposed to sort of separate, have very fluctuating prices. So depending if you are doing everything based on the price in 1 year, you may have a profitable operation, but then half a year later, something happens in the world and all of a sudden the same is no longer true. So this dependence on the price is also difficult. And then the last thing is that, well, is the purity of the streams. So when you sell, say, one commodity would be PET, the PET, one PET recycling, which is sort of the soda bottles, which is actually the highest value commodity price of the thing. When you get a bale of this PET, you get different prices depending on the contamination. So there are strict regulations, and if you have up to 5%, then you get the highest price or something like that. I don't know exactly, but say then you're in the 10-15%, you get sort of a medium price, and well, 70% is the minimum that you need to have, so up to 30%, but then you get a much lower price. But also these levels of contamination and these levels of the different prices, also that is a moving target. Changes all the time. However, I think the trend is in general, the industry requires high purities. And if you have a lot of mixing, it's typically this sort of downcycling to park benches. And there's only so many park benches that the world needs. So then you have these sort of issues to look at. So what we did in these techno-economic analysis, we looked at three things for a current operation. So for example, where is the break-even point? And we looked at a robotics price, the price of the robots themselves. We looked at the commodity price, and we looked at the basically the benefit of increased purity if you can sort of get cleaner recycling streams at the end. And we found that at the time when we did this analysis, robots were they were around the break-even point, and it did make sense. But again, by the time now we're looking back 2-3 years later, and the landscape has entirely changed, because then on the other hand, and I think we have to stop here somewhere, but the competition of the robots in the MRF, which is basically the AI, the vision systems, they have made such drastic improvements that the economics that we calculated 2-3 years ago would have completely changed and now lead to very different things. But it's just important to keep all these dynamics sort of in mind, and I leave it here. Thanks, Berk.
Thank you so much. Definitely would like to hear more about that very soon. I actually would like to say, if you are a roboticist, I really recommend you to go to one of these waste reclamation facilities, MRFs or waste sorting facilities in your area. It is, first of all, they are fascinating facilities, like with a lot of technology happening. We had the like great pleasure to work with Marian Chertow as well. Like big shout out, as well as Amy Wrzanowski. Marian Chertow was the person who was in the team of that built the first MRF in the United States, in Branford, Connecticut. And like, so we had a lot of knowledge about the history or about what is happening right now, or what the future could be. And it has been looking like a very challenging problem, but we should start somewhere indeed. So thanks a lot, Barbara. Minghui, I have two-part question to you actually. One of them is, first I would like to talk about like the technical challenges of the disassembly from a robotics perspective. And then second, we can go into how you establish this human-robot collaboration or enhancement of the human work with robotics. But first of all, from a robotics perspective, what are the challenges of your research?
Great question. Actually, there are a lot of challenges, but if we summarize them, I think it mainly lies on two parts. One is how to let robot know what need to do, and the second one is how to let robot know how to do. So the first one I think is mainly on the intelligence, because you know that the remanufacture, disassemble, is handling some used product. It's not the brand new product. So you have to handle a lot of uncertainties, and you don't know what will be the next product that you need to handle. And you don't know, you need to make a decision which part need to be disassembled, need to be recycled, refurbished. So the robot really have to have such intelligence to automate the procedure. So this is the first challenge. And the second challenge is how to do this one. So even the robot know how to do this, what to do this, what to do, but robot need to know how to do this one. So the manipulation, I think, is one of the key challenges for this process. Disassemble is very different from disassemble because those products are usually designed that easier for assembly than just pushing and they connect together. But for disassemble, it can be very challenging. Usually you have to push some button and rotate something and pull out. And this procedure for robots, especially for our existing robotics facilities, for example, the two-finger grippers, or even for very high advanced robotic hand, it's not easy to complete the whole procedure. As Rupesh mentioned, that there is force feedback and we need vision feedback. We need robot to exactly provide the needed force, and then when it loosen and then pull it out. So yes, so these are two challenges that we need to overcome before robotics can be widely applied to this domain.
Thank you so much. So how do you design robots so that they are working together with humans and enhance their capabilities?
Yes, so because of the challenges, so we involve human in this procedure. So human actually in two loops. The first loop is human robot is doing collaborative task, but they are not physically interact. So humans still do something that robot cannot do. And robot focus on some kind of a little bit repetitive tedious to replace, to trying to do such types of job with a little bit faster speed and more accuracies. So this is the first level that we're trying to do. And for this one, we're trying to optimize the task allocation between human and robot because we need an optimization framework to in real time determine which task need to be done by human and which task can be done by robot. So this is the first level. The second level is how to utilize humans' intelligence to get a robot in such uncertain environments. So we utilize, for example, we do human motion prediction, or we do human force estimation and prediction, trying to let robot to understand human intention. And in this process, human's intention can be served as a decision maker. So robot follow this decision maker and then do some tasks. So basically, we follow these two types of the human-robot collaboration, trying to make robot can work and to increase the capacity of robot in this kind of less structured environments.
Wonderful, really pushing the boundaries of the human-robot collaboration. Thank you so much, Minghui. Rupesh, we actually have a question from audience, which is about the main barriers of robotics disassembly, especially like how can it be made financially viable? What do you think about that?
Yeah, this is a good question. We started off with along the line of thinking, can we disassemble electronics, pull out batteries, PCBs, different valuable components? And, if we have a concentrated, bucket of batteries, some downstream person is going to buy those batteries. And we pivoted into refurbishment about a few months in after we started working on the startup. The short answer is I'm not sure. I don't know if disassembly will, in the near future, become So it's a lot less juice for a lot more squeeze. So laptops, for example, if we can sell a laptop, we can sell it for a working laptop in good condition that someone else will buy. It sells for at minimum $100. But if we pull out the components and sell the battery separately and the PCB separately, it's definitely less than $5, probably less than $1, to be honest. So there's just a lot more value in a working device than a non-working device. And if you think about all the other intricacies we need to get really good at, like unscrewing, plying out batteries that are glued into devices, there's just so many more intricacies down that road that for the time being, there's just lower hanging fruit in this circularity space is what we're trying to say.
I see. So refurbishment is a more viable way you are seeing as financial.
We think so. There's a limited number of things you need to do on the robotics side, at least. You need to open a laptop, plug some cables in, and type some keys. That's true for all laptops. And then if we let most of the diversity of actions happen in the software side, when a camera is pointed at a screen, then you can really, really iterate quickly, and you're not so limited in the way that real life is limited.
Thank you. Thank you so much. That's actually a very important component that that is missing. I think the refurbishment technology is really. I didn't, at least myself, hear about it as much as other aspects of mass management. So, Barbara, you were talking about some challenges that robotics companies were facing, and you were also saying that the landscape was changing as we come to the recent years compared to how it was before COVID or when there was a heavy COVID impact. So with your on your studies, like, what do you observe? What kind of changes were happening? Can you give us some examples?
Yes, I think the sweet spot for robotics very much changes on the times of kind of facility that you're dealing with. So as a MRF operator, the first question is it an existing MRF or is it a newly planned MRF? A newly planned MRF you can design probably today, and I am not... And yes, robotics may have a role, but the role is probably smaller than again a few years ago, or you may not need them at all because there are so many options to efficiently separate the waste differently. However, for existing MRFs, there are sweet spots. Then the next question is: it is a small MRF or a big MRF? A large MRF, then, where you have a lot of quantity, then MRFs, then robots that are relatively large themselves, well, the fixed robots have their role and can be a really valuable addition. While in comparison to the what we call the modular robots, they are a little, well, they are more expensive because, again, they are, but they are sort of, you can put them sort of in different parts of the MRF depending on maybe the daily commodity price. So, or if for a few months it's commodity A you're looking at, but then things change and you want to go after for higher purity for another commodity streams, these modular robots, you can change them, and that is an advantage. The other thing is also that the existing MRFs, for example, they face an issue, or sort of one of the biggest contamination problems or actually operation challenges are plastic bags, because plastic bags, they sort of, they stay, then somehow they get fixed in the conveyor belts, and then the whole operation has to stop. It takes an hour or two to really clean up everything in the worst case. So plastic bags traditionally have been a huge problem. However, with new technology, now they have developed these sort of sucking tubes where you can basically remove them at the beginning of the MRF, and all of a sudden that's no longer an issue. So again, in a newly planned MRF or in a large MRF where you have the opportunity to put these in, then you don't need robots, for example, to pick out the plastic bags. And so that's sort of two things here. But my sense is, And the third thing, of course, is safety, because existing MRFs that are often very, I mean, they are tight spaces. And if all of a sudden you realize as a MRF operator here, I really would need to do some sorting, but the original layout did not allow you to add workers there, and there's just not enough room to add workers in a safe way, then you can add robots, and it's really a win-win, because you do get the additional sorting, but not at the expense of worker safety. I would leave it here for now.
Very interesting. So the problem is basically really depends on what type of facility it is, how new it might be, and what kind of robot technology can be used in which stage, right?
Yes. And maybe one thing to add is also, which goes back to the fluctuating commodity prices, if the robot is doing positive or negative sorting. So are you going, say, in a plastic stream, what a lot of sort of plastics, the two most important or two most valuable plastics are PET and HDPE. So PET you can easily detect through optical sorters, and that's fine. But then the HDPE is sometimes more tricky to get. And if you get HDPE containers like milk jugs, the AI can easily train the robots, okay, you are only going after milk jugs, and then you get the second highest plastics commodity efficiently sorted. So, but again, for that you need higher volumes. That probably makes more sense in larger MRFs rather than in smaller MRFs.
Thank you very much. There's an audience question to all the panelists, actually. Are any of you working with TOMRA recycling? I heard they were close to being able to make a profitable business, taking the black bin waste, which is unsorted non-recyclables, sorting it and extracting value out of it.
Well, I'm not sure about the very latest here, but what this suggests is this would be called the sort of dirty MRFs. So dirty MRFs are those that also include the regular trash. So the idea is that a separate waste collection is too expensive for the communities, people are not participating, etc., and then this makes sense. My first question would be, well, on which continent is TOMRA planning to do this? And I would think that in Europe, this would be much easier than in the US, for the simple reason that in Europe, you do have a mandatory organics removal. So the organics, your kitchen wastes that are really literally messing up your waste streams quite a bit and making everything much more difficult, including visual detection, that part in Europe is mostly removed because people are no longer throwing, or very little throwing, the organics into the trash. So I could well imagine that in Europe that is an option. But I do know, again, I don't know the latest, but also in the US, people are looking into this. And it's probably, whatever people will develop, it certainly will be better than nothing, and you will get better some recyclables out that otherwise you would miss. But is it better? I would then say, is the addition of a dirty MRF and sort of the capital investment that's needed for that compared to the capital investment of having dual stream as opposed to single stream collection, sort of, which makes more sense, probably depends on the context. So.
Wonderful answer, Barbara. And I guess it's also very difficult to talk about specific companies and the performance of their specific products because there are oftentimes actually NDAs that are signed for the companies that are using those products, etc. So it's actually very hard to understand the exact performance unless you are working in a company that's directly using these products anyways, but that was a wonderful answer. Thank you so much. So we will be at the end of the panel. I will just ask a very quick round of questions to finalize it. So first of all, I will ask to everyone, how can the broader climate robotics community support you? Are you hiring? Are you looking for like launching projects in other countries? Are you looking for collaborators? Are you seeking funding? Can we have a very brief round on this?
I can go first.
Oh, sure. Yeah.
Or was there an order you had in plan, or is anyone?
No, please go ahead.
Cool. One thing that so we're going to start recruiting and hiring very soon, probably sometime this summer or late summer. So please keep your eyes open on our maybe LinkedIn page is probably the best one to keep track of at Revised Robotics, and you can find me on LinkedIn too. One larger ask would be if you know anyone in large enterprise companies who deal with these all these IT assets from all their employees, maybe customers, and a lot of their refurbishment processes. If there's an introduction you think you could make, we'd really appreciate it. Thank you.
Thank you so much. I also would like to encourage everyone to join our Slack channel where also these conversations are happening. But thank you so much, Rupesh. Minghui?
Yeah, I'm looking for some especially industry partners because I think this problem can not only do from academia technology, we also need to consider real industry challenges. So yeah, if you are interested, feel free to send me emails. Thank you.
Thank you so much, Minghui. Barbara?
Yes, thank you. So I currently don't have an ongoing research project that particularly looks at robots in waste management. However, I am involved in the Remade Institute, which is in the US, a big manufacturing USA institute, public-private partnership that does that supports research around technical solutions towards the circular economy. And we have actually also a special, and I'm involved there. And this is we have the MERF Next Gen, sort of a special research project around that. So anybody who would like, and we facilitate networking between both industry partners, so both and academics. So for example, WPI and Yale, we are both partners. So if you have an industry or a novel technology, you can, if you're interested, you become a member, and then we can see, can we collaborate together, do something, seek external funding. And I would just in general encourage checking out the Remade website, and I will put actually a link in the chat. Thank you.
Thank you so much. And the profiles and information of all the panelists are posted in our chat if you would like to connect with them. And one last round, and maybe a very quick one, is your hot take. So this can be a contrarian or provocative point of view about your sector, about the research domain, about the companies, anything. So Rupesh, would you like to start?
Yeah, sure. I think my provocation would be that so in the sector that we're working with in e-waste, a lot of the devices and the manufacturers, OEMs, manufacturers are doing nothing, even less than nothing in this space to combat electronic waste and refurbishment and circularity, ranging from anti-consumer practices like disabling right to repair or disabling your ability to replace your cell phone battery or parts pairing. There's a lot of things that consumers can learn about in this space and demand more action from producers. Voting for people who advocate for extended producer responsibility, take-back programs. There's so much greenwashing also happening at the same time where manufacturers are, saying like, hey, look at this robot that we've made that does this, this, and this, but it's not actually driving a circular economy because it's not in their best interest too. So regulation has played a huge part, especially from the EU, but also rising in the United States through right to repair. We should be demanding more action from lawmakers and policymakers alongside the robotics and technology that we're building.
Thank you so much. This actually indicates that the policy aspect, we can just have a complete another session about the policy aspect of waste management, isn't it? Thank you so much, Rupesh. Minghui?
Yeah, I think robotic technology need to be better and cheaper to make sure that it can actually positively impact this domain. And I think to achieve this, we need to work together, academia, industry, policymakers, federal agencies. Yeah, that's my message.
Wonderful. Yeah, totally agree. And I hope the network helps for that. Barbara.
Well, maybe just looking at sort of the two topics that came up in this panel is to use robotics in e-waste and in municipal solid waste, sort of in these MRFs. I would argue that the future probably lies with e-waste and not with the MRFs, just because in the e-waste system you need disassembly. You don't need disassembly in the MRF, and you have higher commodity values because you have, as Rupesh explained, you have all these high value specialty metals that are included, and it just seems like a much more also accountable or sort of predictable sort of future than in the MRFs. That would be my take here.
Thank you so much, Barbara. That was definitely a hot take. And I also see that you are writing an answer to one of the questions at the QA panel. So thank you so much for that. But we need to finalize it here. So thank you so much, all the panelists. This was a very fruitful, very thought-provoking panel, and I learned a lot from that. So I will finalize it here and pass the ball to Stefana. Thanks again.
Thank you.
Thank you.